In this lecture, we will discuss about the recurrence relation corresponding to the Bessel function. In the previous lecture, we have already deduced first four formula, and in this lecture, we will deduce formula 5 and 6, and we will show some of their application. So this is formula 5. Here we have to deduce that ddx of x to the power minus n into jn is equal to minus of x to the power minus n jn plus 1. Now from recurrence formula 1, we know that x jn prime is equal to n jn minus x jn plus 1. Now what we will do, we will multiply x to the power minus n minus 1 with this equation. So we are obtaining after multiplication x to the power minus n jn prime is equal to n x to the power minus n minus 1 jn minus x to the power minus n jn plus 1. So we are writing this formula as x to the power minus n jn prime, and one term we have kept in the left hand side. So minus n x to the power minus n minus 1 jn is equal to minus of x to the power minus n jn plus 1. Now these two terms simultaneously can be written as ddx of x to the power minus n jn, because you see if we differentiate, so it will be first term is x to the power minus n, then jn prime, then next minus n into x to the power minus n minus 1, that is derivative of this term, and keeping jn constant. So these two terms can be written in this way. So this is formula 5. Now let us check one example of the application of this formula. We have to show that integration 0 to x to the power minus n jn plus 1x dx is equal to 1 by 2 to the power n gamma n plus 1 minus x to the power minus n jn x. So from the formula 5, we can see that ddx of x to the power minus n jn is equal to minus of x to the power minus n jn plus 1. So we have just written formula 5. Now we are going to integrate this equation. So this dx will be transferred in the right side. So left side is d of x to the power minus n jn x, and dx has been transferred here. So if we integrate, then this will become 0 to x, this is right side, so our right side we are writing at first. So right side is x to the power minus n jn plus 1 dx. I have already told that dx has been transferred in the right side. So then we are integrating. So integration of the right hand side will be x to the power minus n jn plus 1 x dx. And integration for the left side, we have kept negative sign in the left side, and negative side is d of x to the power minus n jnx. So integration of d of x to the power minus n jnx will be x to the power minus n jnx, and limit is 0 to x, and there is a negative sign over here. Now if we put the upper limit, then first term will be minus of x to the power minus n jnx, and putting the lower limit, we can write this expression in this way, that is limit x tends to 0 and jnx divided by x to the power n. Now we have already evaluated the value of jnx divided by x to the power n in some early examples. I request you to check that example, although I have discussed in the first lecture about that example. Just I am showing you, that is how to calculate that term. This one, that is limit x tends to 0, jnx by x to the power n is equal to 1 by 2 to the power n gamma n plus 1. We have to see example 2 very clearly for the derivation, that is limit x tends to 0, jnx by x to the power n is equal to 1 by 2 to the power n gamma n plus 1. So we are just using that result only. So here we have used that result here in this place. So ultimately what we are obtaining, that is 0 to x to the power minus n j n plus 1 x, that becomes 1 by 2 to the power n gamma n plus 1 minus of x to the power minus n j n x. So it has been proved. Now let us discuss about formula 6. Formula 6 is ddx by ddx into x to the power n j n is equal to x to the power n j n minus 1. We have to show that. Now we know x j n prime is equal to minus n j n plus x j n minus 1. That is the recurrence formula 2, which has been discussed in the earlier lecture. Now we are multiplying by x to the power n minus 1 both side. So after multiplication we are obtaining x to the power n j n prime is equal to minus n x to the power n minus 1 j n plus x to the power n j n minus 1. So after rearranging we are writing in this fashion, x to the power n j n prime plus n into x to the power n minus 1 into j n is equal to x to the power n j n minus 1. So these two terms can be written ddx of x to the power n into j n, because if you differentiate x to the power n into j n, then you will obtain these two terms. So left hand side can be written as ddx of x to the power n j n, and that is equal to x to the power n j n minus 1. This is formula 6. Now we will show some example. Like we have to prove ddx of j0x is equal to minus of j1x. How to show that? Recurrence relation 6 is ddx of x to the power minus n jnx is equal to minus of x to the power minus n jn plus 1x. Now if we put n is equal to 0, then this left hand side will become ddx of x to the power 0 into j0x, and the right hand side will become minus x to the power 0 j1x. That means ddx of j0x is equal to minus of j1x. Another example, we have to show that integration x j0 square x dx is equal to half x square and in the bracket j0 square x plus j1 square x plus c. So what is the left hand side? Left hand side is x into j0 square x into dx. Now we are doing integration by parts. So the first term will be j0 square x into integration x dx, that means x square by 2 minus integration j0 square, that is becoming 2j0 into j0 prime, and x square by 2 as it is, x square by 2 dx plus a constant. Now in the earlier example we have already shown that j0 prime x is equal to minus j1x. So j0 prime x for this value we are putting minus j1x. So you see that for j0x we have written minus j1x here. So the second term becomes x into j1x into x into j1x into x into j0x dx plus c. Now putting the value of x j0x from recurrence relation 6, we get, that is x j0x we have already evaluated the value of x j0x. You see the formula. This is the formula. So from this formula we can calculate x j0x. If we put n is equal to 1 here, you see, so this will become x and this will become j0. So that they are saying actually, that is putting the value x j0 from recurrence relation 6, this term can be written, that is x j0 can be written in terms of ddx of x j1x. This is from recurrence relation 6. So we are writing in this way. So x j1, you assume that x j1 is equal to t. So x j1 is equal to t, and ddx of x j1 into dx. So dx will cancel, so this will become dt. So ultimately this will become integration t dt. So integration t dt is equal to t square by 2. So t means xg1, so xg1 whole square by 2 plus c. So just after a little bit of rearranging, this is becoming x square by 2, and in the third bracket j0 square plus j1 square plus c. So in this way it has been proved. Another example, suppose we have to show that jn plus 3 plus jn plus 5 is equal to 2 by x n plus 4 jn plus 4. So how to prove that? Here we will use recurrence relation 4. So recurrence relation 4 is 2n jn is equal to x into jn minus 1 plus jn plus 1. So this can be rearranged like this: jn minus 1 plus jn plus 1 is equal to 2n by x into jn. Now if we put n plus 4 in place of n, so left hand side will become left hand side of this question, that is jn plus 3 plus jn plus 5, and in the right hand side we can show that this is becoming that right hand side. So this can be proved in this way. And express j for x in terms of j0 and j1, although we have already discussed in earlier lecture, that is how to reduce j term. So for this purpose we have to use recurrence relation 4, because this relation will show you that is how the higher j values can be reduced to the lower j values. So consecutively what we have to do: at first we have to put n is equal to 1, then j2 can be expressed as j1 j0. If we put n is equal to 2, then j3 can be expressed as j2 j1. If we put n is equal to 3, then j4 can be expressed as j3 and j2. And ultimately what you can show that j4 can be expressed in terms of j0 and j1. Another example, for example, suppose we have to show that j2 prime x is equal to 1 minus 4 by x square j1 x plus 2 by x into j0 x. So how to show that? We are using recurrence formula 2. Recurrence formula 2 is x into jn prime is equal to minus n into jn plus x into jn minus 1. Now if we put n is equal to 2, then this equation will become x j2 prime is equal to minus 2 j2 plus x j1. So j2 prime we can write as minus 2 by x j2 plus j1, just a little bit of rearranging. Now recurrence relation 1 is x jn prime is equal to n jn minus x jn plus 1. So actually what is our aim? You see that in this expression we have expressed j2 prime in terms of j2 and j1, but in the question you see what is the right hand side? In the right hand side you have to express in terms of j1 and j0, but here by using recurrence relation 2, j2 prime has been expressed in terms of j2 and j1. But from the formula 4 we have already discussed that higher values of j term can be expressed in terms of lower values. So if we use formula 4, I mean this formula, that is 2n into jn is equal to x into jn minus 1 plus jn plus 1, or jn plus 1 that can be expressed as jn and jn minus 1. So here if we put n is equal to 1, then j2 can be expressed in terms of j1 and j0. So we have to use formula 4 for reducing higher j values in terms of lower j values. So just we will use that formula 4, and we can show that j2 is equal to 2 by x j1 minus j0. So I am again just explaining that here j2 prime is equal to minus 2 by x j2 plus j1 we have already shown by using formula 2. So this j2 can be expressed as 2 by x j1 minus j0 directly from formula 4. Here we will not use the tricks applied in this book, just we will express j2 by using formula 4. So we will write the value of j2 here. So then we can easily show that j2 prime that can be expressed as 1 minus 4 by x square j1 plus 2 by x into j0. So in this way those recurrence relation can be used in different types of application. And the content of this lecture is from the book of Das Verma, and I will request the viewers to go through a huge number of examples that has been solved in this book, and after going through these examples I request you to solve the exercise part in this book. There are varieties of problems here as example, so I request you to go through all the problems. then you will understand the application of the recurrence relation in different types of problems. And I thank you all who have listened this lecture.